So we have this problem here, right? Find the unit digit when we substitute 1000 for n in here. Now, when we do that, f of n, 1000 right here, equals 2 to the power of 2 to the power of 1000 plus 1, right? At first glance, this looks a little complicated, so let's try to simplify it now. So let m equals 2 to the power of 1000, which is the exponent of this. So now the equation is f of 1000 equals 2 to the power of m plus 1. Now, we need to find the unit digit of this, right? Because we need to find the unit digit of this and then add it to 1. So how do we do that? Well, we have to first look for a pattern in the unit digit of the powers of 2, which means we must have m here, and then we have 2 to the power of m, and then we have the unit digits, right? So when m equals, let's say 1, 2 to the power of m is 2 to the power of 1, and the unit digit is 2. When m equals 2, 2 to the power of m equals 2 to the power of 2, this is 4. When m is 3, 2 to the power of 3, 8. M is 4, 2 to the power of 4, 16. Now this is double digit, so we have to underline that. 5, 2 to the power of 5, 32. 6, 2 to the power of 6, 64. And 7, 2 to the power of 7, 128. 8, 2 to the power of 8, 256. And so on and so forth, like that. Now, from here, we can tell immediately that there's a pattern in the unit digits, which is grouped into 4. So we have 246, 2486, 2486, and then so on. It's grouped of 4, right? So let's say we have a larger number of m, which means, let's say m equals 17 as an example. So we need to find how many groups of these unit digits are in 17. So we do 17 divided by 4, which is the number of unit digits, and we get 4, and then we have a remainder, which is 1, right? So that means there's 4 groups of this, and then there's 1 left over right here. So that means we have to look at the remainder, which is 1, so that means it's 2. So we can add another column here, remainder. So that means when the remainder is 1, the unit digit is 2, the first one. So let's say m equals 18 now. 18 divided by 4 equals 4 with a remainder of 2. 2 corresponds to 4, right, after 1. So it goes here. M equals 19. 19 divided by 4 equals 4 with a remainder of 3. And now we have a remainder of 3, so it goes here. And it corresponds to 8. So, and then we have m equals 20. So 20 divided by 4 equals 5. No remainder. So that means this is 0. Because if we have a divider of 4, and this number is divisible by 4, and this is the 4th number, that means there's no remainder, right? So it can't be like 4 or something. So 0 corresponds to 6. So now, with this pattern in mind, so on. With this pattern in mind, we can finally plug in m equals 2 to the power of 1000. So 2 to the power of 1000. So now we have 2 to the power of 1000 divided by 4, which is equal to 2 to the power of 1000 divided by 2 to the power of 2, which is equal to 2 to the power of 1000 minus 2, which is 2 to the power of 998. Now, this is no remainder, right? So we now know that m must correspond to the number 6. So now we know that the unit digit of 2 to the power of 2 to the power of 1,000 equals 6. Now, solving the problem, the function, the unit digit of that is f 1,000, 2 to the power of 2 to the power of 1,000 plus 1, which is equal to 6 plus 1, which is equal to 7.